In this lesson, we're going to take a look at solving quadratic equations, specifically using the methods of factoring and completing the square. If we start with factoring, I've just made an already completed example for you, and I've put the steps there. Remember that you've seen this before. Your goal is to get everything set equal to 0, to factor, and then to set each factor equal to 0. So in this example, it already was given to us as being set equal to 3. Therefore, I want to minus 3 from both sides. Since I get x squared plus 7x plus 12 and it has a leading coefficient of 1, then I can just factor this by asking myself what numbers multiply to give me 12 but add to 7. And those numbers are 3 and 4. And so my factors become x plus 3 times x plus 4. And if I set each of those equal to 0, then I get my solutions of -3 and -4. And written in set notation, that's -4 comma -3. So every time you want to solve a quadratic, it may not be able to be factored though. So that's where we learn a new method of solving by completing the square. And solving by completing the square will always work. So what we want in order to solve by completing the square is to have our very first leading coefficient to be 1. So if that isn't the case, I'm going to just divide everything by that leading coefficient to force my equation to start with 1. Then I want to get the x squared and x terms on the left-hand side by themselves. So I'm going to push everything else over to the right-hand side. I'm going to find that last term to force what I have to be a perfect square trinomial. Then I'm going to factor that, and I'm going to use the square root property to get x by itself. And when I do that, I don't want to forget about my plus or minus. So let's actually apply those steps. So again here, remember, when I was factoring, I want it set equal to 0. When I'm solving by completing the square, I don't care what it's equal to. I just want these first two terms, since my leading coefficient is 1, to be by themselves. So I want to subtract off the 15 here, and I'm going to subtract it off from the 3 as well. So now I'm left with x squared plus 7x, and it equals a -12. Here I've left some space for myself because in completing the square, remember we added in a last term. So I want to add in a term there. Whatever I do to the left, I have to do to the right. So I'm going to kind of set it up for myself. Right? So I want to figure out, well, what is that last term? We just completed a lesson on that. So I know this last term is going to be half of my middle term squared. So that's going to be 7/2 squared. Okay? And then I'm going to add the same thing in over here, right, to keep my equation balanced. So now this factors, we forced it to be a perfect square trinomial, so it factors to be x plus 7/2 squared. And on my right hand side, if I add that together, this is going to simplify to give me 1/4. Since I have something squared and I want to isolate that x, I want to take the square root of this. And when I take the square root, it's so important that I don't forget this plus or minus. That's our most common mistake. Okay, so I'm going to take the square root of both sides. And when I do that, I end up with just x plus 7/2 now is equal to the square root of 1/4, which we know to be 1/2. And I'm still not forgetting that plus or minus. Last thing is to isolate my x, so I want to minus 7/2 because it's being added right now. And I'm going to minus that 7/2 over to the other side. So I have x equals -7/2 plus or minus 1/2. Whatever I minus, I want to put in front of that plus or minus. Now this I can actually simplify. So this is really two problems. It's -7/2 plus 1/2, and it's -7/2 minus 1/2. So if I solve that, this is going to give me the set of two solutions. -7/2 plus 1/2, that gives me -3. And -7/2 minus 1/2 gives me -4. So my solutions are -4 and -3. Let's do one more example where we complete the square. And this time I want to give you an example where our leading coefficient is not 1. And the only thing that's different here then is the very first thing that you're going to want to do is divide both sides by whatever it is that's forcing it to not have a leading coefficient of 1. So in that case, this is our leading coefficient. It's 2. I don't want it there. So I'm going to divide both sides by 2. Okay, that's going to give me x squared plus 5x plus 6 is equal to 3. And now I want to complete the square. So I want to isolate these first two terms. So I'm going to minus 6 from both sides. I have x squared plus 5x is equal to negative 3. But notice I've left myself a blank because I'm going to add in something on the left and add in something on the right so that I can complete my square. So I'm going to choose to add in my last term, which is going to be half of 5 squared. So this is going to be 5 halves squared, and same thing here, 5 halves squared. So this factors then to x plus half that middle term, 5 halves squared. That's why it was so perfect. That's why we added in that last term the way we did, so we could be able to write it just like that, something squared. And that's equal to 13/4 if I simplify the right-hand side. And since I have that squared, I want to take the square root of both sides. That's going to give me x plus 5 halves is equal to, I almost forgot, don't forget that plus or minus the square root of 13 I don't know, but the square root of 4 I do know, that's 2. So I want to minus the 5 halves then, so that x is by itself. I'm almost done. So x is going to equal negative 5 halves, because I minus it from the other side, plus or minus the square root of 13 halves. So we write our answer in set notation. We can be lazy and just write it as the set of negative 5 halves plus or minus the square root of 13 halves. Or we can write our final answer out and show what our two solutions are, which would be negative 5 halves plus the square root of 13 halves. Actually, we want to go smallest to largest. So we want the minus to be first, because that'll give us our smallest value. Comma negative 5 halves plus the square root of 13 halves. Okay, so either answer would be correct. Right, to challenge you, I'm going to leave you with this last example. I want you to solve this by completing the square. I've already gotten it so that you don't have a leading coefficient other than 1. And so since that leading coefficient is 1, you can just go ahead and start to complete the square. And unfortunately, this does not factor, so that's your only option. And if you do everything correctly, you should end up with a solution that includes imaginary numbers. Good luck.